Good morning, everybody. Welcome to 109th episode of Tech Forum. And today we are having Mr. Ashok Saraf, who will be talking about reverse engineering process. And this is going to be interesting. This is the second talk about this topic. And we will be interacting with Ashok on this topic. Ashok Saraf is a alumna of IIT Mumbai. He did his BTech. After that, he was one of the Indian selected for Philips International Scholarship, where he did his graduation at Philips Eindhoven. He was the only person in India who did not join Philips after completion of the education at Philips Holland, and then he had worked with various industries, including Tata Motors, Accurate Engineering, or you name Electronica. A wide experience, and he is a good professor and good teacher. I have enclosed his biodata, so I need not read it. It's a very long biodata. Those interested can go through the attachment with my mail as well as the WhatsApp. Without spending much time, I will request Ashok Saraf to start his reverse or object-oriented engineering. I request Ashok Saraf to start his presentation. Over to Ashok.
Good morning, Vilas. Good morning. I will just remember the Guru Brahma.
Please go ahead, Ashok.
Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Sri Guruve Namah. Akhanda Mandalakaram, Vyaptam Yena Characharam, Tatpadam Darshitam Yena, Tasmai Sri Guruve Namah. So my senior Vilas Rabdeji has started this tech forum, which is bringing, like a guru, lots and lots of technologies for the benefit of ecosystem around. So thank you, Vilasji, for inviting me for this lecture. Now, taking this further, any source of knowledge or information, especially knowledge, which brings us to the new world which we did not know before, is a guru. So guru concept is very, very deep and wide in our culture. Now, have you ever wondered how the totally illiterate person on the roadside understands about the bikes and vehicles and repairs them for you? You do not look for his certification, nor do you take his examination. Often he may not be able to even make a drawing or take or describe the functioning, but he is still capable of putting it right. Not only that, he can fully dismantle it, service it, clean it, and assemble it, whether it's cycle or a bike or things like that. So obviously, we have a capacity, innate capacity within our mind, our brain, for taking apart anything and learning about its structure, its internals. And this I'm calling as object-oriented engineering or reverse engineering. So engineering discipline is very wide, and we are tuned to knowing engineering through body of knowledge, textbooks, formula, mathematics, learning by lectures, solving problems, understanding the functions. And often we completely neglect this very simple pathway available for giving a working knowledge of any object simply by looking at it objectively, like an object, without looking into its function. So believe me, I've tried to explain this and make various students or engineers practice it, but it takes a lot of time for them to capture this concept. And every now and then they think of the engineering functions, classification of objects, as electrical, mechanical, plastics, and therefore do not capture this plain, simple, vastunishta or object oriented approach to look at the things. Whereas a child, by nature, given a toy, you would have always experienced that he or she would like to dismantle it, break it. So that is an internal urge to really look inside, to look into the unknown, the curiosity, to break open. Now, if we make this breaking process a very systematic process and we also learn to document it well, then you will be amazed that it opens up a door for a new way of engineering of products or objects which already exist around you. Can you go to the next slide, Vilas? Please, next slide, please. Yeah. There are many things written here, but these are all points that you can read. What I would like to emphasize is this. When we start with a existing object or a product for analyzing it and understanding it to derive knowledge and information out of it, that product already is there. It's there in the world. It is being sold. It is being manufactured. It is being made. I'm talking about man-made products. Engineers take care of man-made products. Natural products are taken care of by nature. So we are restricting to engineered or man-made products. In the world of development, you are aware about the technology readiness level of an idea converted into a prototype, lab level prototype, field level prototype, and so on. After this series of TRL 0 to TRL 9, TRL 10, comes the MRL, that is manufacturing readiness levels, technology readiness levels, then manufacturing readiness level. MRL 10, the highest level, is when the item is proven and manufactured, the toolings are done, everything is, processes are set, and it is in manufacture and available in the field. So when you are picking up a product, let's say this pen, for example, it's there in the market. So it is already reached MRL 10 level. So it's fairly advanced in the chain of idea to product. So that's an advantage to get started. Now, if you look at a product, one can conceive different ideas. Like, for example, by looking at the pen, we might think of it as a writing instrument, the functioning of it, the uses of it, the price of it, cost of it. Keep that aside. Try to look at it as a thing without looking at its function. Man-made things are usually assembled from various other sub-assemblies and parts, and all these things are made of material. So materials, component parts, sub-assemblies and assemblies is what is inside a product. So if we look at it from that point of view, let's say look at this pen. If you divide it into, let's say, two parts, you try to break it. The simplest way to break it is by opening, and then you have a cover and you have a body of the pen. So a pen consists of this part and this part. Okay. Now you keep one part aside, only look at this part. This is also a product, a cover. Try to break it open. See what is there inside. Okay. There appears to be some tube like body and a pen cover and an item which you can call clip. Very often, when you go further, you will run out of names. You won't know what to call them. So, in that case, simply assign some identity or a number. You have to give a number so that we remember it and we can recognize it afterwards. We can document it. So, when you divide this main object into two parts, suppose we call it 1 and 2, or let us say A and B. So, A is a cover and B is a body. Now, when you take this A, we are splitting it into two parts. So this is one part of A, this is another part of A. Now this is a very interesting concept which I hit upon accidentally in trying to manage this process of reverse engineering for a large class of engineering students in Saharanpur. I said, how do I keep track of at what level students have broken these things? Then like a flash came to my mind that at the second level, instead of numbering them as A, B, C, D, I will enumerate them as 1, 2, 3, 4. So this is A1 and this is A2. Clear? So cover was A, the whole cover, and body was B. And now we have A1, a clip, and A2, a cover tube. So this cover assembly is now split into two parts, A1 and A2. Now we take one of these. We take this A1. What is there this in this A1? Try to look very closely. What do we see? Well, I can see that there is a plastic part and there is a threaded insert. There is some kind of threading in the cover. So we have A1 divided into again two parts. A1A, which is a clip, molded clip, and A1B, which is a metal insert, which is, well, it is not metal. Oh, I'm sorry. It looks like not threaded insert. It is just like a plastic insert. If I look closely at the clip and the cover, then I find that actually that plastic part was a part of the tube which I broke while pulling this. Oh, so now we understand that that plastic is same as part of this A2 and it is not threaded insert, though it initially looked like this. So this is the kind of thinking you go in you do in your mind in identifying, separating and identifying. So while separating, it should be very clear that it should be distinctly separable and integral part. And at this level, if you split it into say even A and even B, there should be nothing left. So separable means these two, this set of objects should be disjoint. That means they are separate. And the union of all these disjoint parts, collection of this must result into total object at the higher level. So this in disjoint and union forming the total. That means nothing is duplicated and nothing is missed. These are very important rules. Oh, I'm sorry. If you look at the video, then you can see what I'm talking about. Okay. Now we take A1A, which is this plastic, blue color plastic clip. I see that there are still some more things in that. There is some kind of a printing. There is a printing giving the name cello, fine grape, S, and so on. So this part A1A has got again A1A1, which is the molded body, and A1A2, which is a printing. Printing is by an ink. It requires certain material to be deposited on this plastic. Okay. Then we take this B, and in the same way, you take apart into two or three things. So I can take out this front, the front cover, refill, and back cap. So main body, back cap, refill, and front cover. So this B is split into four parts: B1, B2, refill B3, and the back cap B4. So B is now divided into four parts. B1 is the main body. Okay. Look at that. Then you again find that there are two parts in it. There is a molded pen body and a sleeve, a holder sleeve. So B1 is split into two parts, B1A and B1B. Okay. I can't break this further. They are apparently integral part. They cannot be disassembled. B2 front cover is also an integral part. So this is a terminal part. Below this, there is no child part. So B1, B2, and B3. B4 is refill. Refill is an assembly. There are things inside which can be separated out. And B4, a back cap, is again just an object. I can't split it further. So we have got B1, B2, B3, B4, and this refill. Let's call this B1, B2, B3, B4, B5. This B5 can be further dismantled. If you try to dismantle, then you will see this B5A is a plastic tube, B5B is a ink, and B5C is the front nib, which you can pull out. Now, I'm not going to pull out because it will be messy. There is the ink inside. But often in the childhood, we have broken these. So when you pull this out, you got B51, sorry, B5A tube, B5B is ink, and B5C is a nib assembly. You take the nib assembly and you try to break it further, you will see nib body. So B5C1 is a nib body. B5C2, there's a ball inside. And B5C3, if you really break it down and see, there might be a small spring inside to hold the ball in the front. So that when you press it, it goes inside and the ink comes out. Now we have gone to a smallest level in all the branches of this simple product, starting with full pane. Now we can go in the reverse order to assemble it. So I take this, I put the back cap, front cap. So it has fallen down, so I keep it up. Now this, when we are doing separating and giving names, you can see that I'm forgetting the names as I'm talking about it. So what we need to do in reverse engineering exercise in practice is as soon as you split at one level, you make labels. And in order to keep these small parts safe, you put them in the bags, plastic bag, or you can even take a old newspaper and make a pudi, but isolate them. Physically protect them, isolate them. They should not get mixed. And put a label on that part so that you know precisely where that part belongs. And this number which we are assigning, I'm calling it as an assembly part number. It is a part number of some kind. It is useful for assembly. So we call it APN number. Now in this case, there were only one-off items. There might be items like fasteners, and you might separate two parts with 4 screws acting as a third part, assembling them. So at that time, screw is an item, and you can write quantity 4. So APN can be just one number and quantity can be 4. Now by looking at the numbers and going from bottom to the top, we can assemble a product. We are not bothered about understanding the product. We have not understood the physics of it. We don't even know the functioning application, that is how to use it. We don't know. But we can take it apart and we can assemble it simply by remembering a sequence in which we disassembled and thereby following a sequence of assembling in the reverse order so that we can disassemble and reassemble the same object. Is this clear? I think it is extremely simple, but if you actually do this process yourself for any item, let it be a shirt or a bag or a lock, a chair, or a mobile phone if you are very ambitious, or take a simple thing like a LCD display, and try to go down and down and down till the smallest level. For example, if we want to go still further down in this ink which is printed on this A1B, which is a clip, that ink further can be broken down if you have access to that ink. If you can scrape it and analyze it, you will find that there is a solvent and a dye. Okay, so this can go on and on till the lowest level up to which you have access to materials, so that you can bring those materials and reconstruct this object. Okay, next slide, please. So this is the way we are breaking down any object, main object or a product, into a subassembly A, subassembly B, another part C. Then within A, there is another subassembly. This is a hypothetical object. This is not related to the pen, but you can understand it. Then there is A2, which is a part. The B is divided in B1, which is a part, and B2, which is a part. Within A1 subassembly, there is a part A1A, and so on. Can you go further down? Vilas, can you go to the next slide? So same thing can be shown in a hierarchical diagram like this. A1, A1A, A1B, that is A1 consisting of A1A, A1B, and A consisting of A1, A2, and so on. Next slide. So the same structure view, because of this numbering, even if it is in the form of list view, simply by looking at the name, you know the level at which the product is and who is the parent of that product. So this is a list view, which is typically what we have in a bill of materials. So by dismantling an object, dismantling a product, we can create bill of materials. And by naming the products in a systematic fashion with alpha at one level and numeric at the next level and alternating it again, we can have a list view so that we know precisely where that part or material belongs in the main product. Next slide, please. Now, reverse engineering process brings you to the bill of materials. That means you get a list of materials, but it is useful for keeping track to not to miss out any objects when you reassemble them. But how can we make use of it uh, for entrepreneurship or for setting up a production? Now, for each of the material in the bill, in the BOM, there has to be a process. So a simplest process may be purchasing process to acquire that product from a market. So when you go to the market, you can't say, give me this A1B, which is looking like this. Of course, you can take a sample, you can make a drawing, you can take a CAD model. Then you go to the market, find out if it is a standard item, then you know the manufacturer, you have manufacturer's part number for it, and that is when you can purchase it. You may have manufacturer 1, manufacturer 2, manufacturer 3, each one having his own part number to it. So you have MPN, manufacturing part number 1, MPN 2, MPN 3, to get 3 quotations from 3 manufacturers. So a purchase process can be defined for purchasing this material, or the material may be machined. A part may be machined by acquiring a raw material and then machining it. So machining will be a process. You can describe the operations of that machine. It might be turning, finishing, facing, and so on. Or it might be an assembly. So the assembly process can be also described. So you can create a document of the process, and for each part, that document reference number can be listed in the as a column in the BOM, so that for every part you have a BOP, bill of process. So a bill of process is a list, and list of processes required for each part in the bill of material. Now, any process in order to produce quality, that is to make a part or assembly the way it was meant to be, requires to be inspected or tested. So there is to be a document describing, for example, if we have a pen and we have a process for molding of this clip, there has to be a process to make to identify the dimensions which are critical. For example, this internal diameter which is going to go in the cover, if it is loose, if it is wide, then it may fit loose and the clip will come off. If it is too tight, it may not go inside. So the fit has to be as per the tolerance available for production of this mating part. So quality plan or inspection plan or a test list or a testing document is also associated with every part or assembly. And the list of these is bill of testing. So in the same list of BOM, you can add a column and put the document number where you describe the procedure for testing, the instrument to be used, the measuring procedure to be followed, the tolerances, and how to decide whether it is acceptable quality or not. All this information can be in a testing document or an inspection plan, and that document can be referred to in this list of parts in the BOM itself as one column, and that column is BOT, bill of testing. For every part that is supplied by vendor, there is a supply chain transport process. There is delivery chain also associated with some sub-assemblies. You may give some assemblies to some other plant. So material handling processes can be also defined and described for every part, and this knowledge can be added into the BOM. Today, manufacturers are held responsible also for the recycle process. So even that can be defined, and therefore, starting from a product, all these bills of materials, processes, testing, supply chain transport, delivery chain transport, and recycle, all of these can be uh, brought into one document with proper understanding simply by looking at it as object. Okay, with little knowledge of engineering for processes and testing. Next slide, please. Now, why do we create such lists? Everybody knows that manufacturing an item, really bringing it to life with hundreds of thousands every day, is a very complex process. Imagine manufacturing Boeing 787. Imagine even manufacturing the automotive vehicle. There are hundreds and thousands of parts. So there is a complexity. So we know all in companies that divide and rule approach is used for dividing the whole into parts. And then you have processes for each part and processes for assembling them. So that is how we can handle the complexity. Now, if you make this list and generate this information, that can be a good starting point for taking decisions and working out scenarios. If something is changed, what other things will get impacted? Because you know the interrelationship of parts within a product. Okay. So you can even plan strategies related to production, distribution, recycling based on this fundamental information. Often, without this information and knowledge, people end up reacting to the situations and hopefully try to compete with the world class manufacturers by deriving that knowledge as they go along. But if you start in a systematic way, and if you start with a product, which could be a product which is in the market, or it could be even a product which has come out of idea from a lab into a field and tested in the form of available in the form of prototype. But even that, usually the process of creation, because it doesn't follow the systematic documentation of how it is to be produced, how it is to be assembled or disassembled, often being made by scientists and engineers in the lab, doesn't carry that documentation. So reverse engineering is not only for imported products or copying somebody else's product, but it is a process for even looking at your own prototype in a critical manner and handling the complexity of that by average people who will be working in your actual manufacturing. Next slide, please. So this is just an example of how APN is very useful. Look at the number. The number is pretty long, A1C5, D3, D12, but it very precisely describes the position of that part in the total hierarchical structure of that product. Okay, it is a 12th part in the A1C5 B3D assembly, which is a dth part in A1C5 B3, which is the third part in A1C5B, which is the bth part in A1C5, which is the fifth part in A1C subassembly, which is the cth part in subassembly A1, which is the first part in the assembly A, which is the part of main product. Next slide, please. Okay, so I think the idea should be clear by this time. Now, there are people who say, why this method is being proposed? Where did I think of it? And the story goes like this: that about 40 years back or 42 years back, when my son was about 5 years old, we were coming down from Jezuri by ST, and as a time pass game, I just thought of asking for. I said we'll play a game of Rachana, and I will tell you an object. Let's say in the ST lamp, there was a lamp on the roof. I said the lamp is consisting of a cover, a lamp inside, and some wires. And then I said, okay, you ask me some object, I tell you the Rachana. Then I tell you some object, you tell me the Rachana. Now, believe me, within about 10-15 minutes, we were going from physical things to even abstract things. And we started talking about, tell me the structure of music. And I was zapped. I said, this 5-year-old boy and myself, we are within 15-20 minutes, we have got into a dialogue for critically analyzing things. And I realized the power of the concept of structure, which we all know in the manufacturing industry as well as in software. The structure carries very important methodology and a source of knowledge of relationship of things or objects. Okay, now there was a situation in Corona time when we were looking at videos where people were dying and they could not breathe, and the breathing machines or ventilators were not available. So many people were thinking about it. I was thinking, suppose these electronic parts are not available if China is closed down. Is there any kind of design which we can take? Then Bharucha's name came up. I think Martin told me. And then I contacted Bharucha. And Bharucha's ventilator, which was a pure mechanical device assisted by motor to make it electromechanical, but did not use any electronics, was in use for more than 40 years. And it was still working well in some, one doctor assured that, well, he has been using it. He was anesthetist. And he says it is wonderful. There was another doctor, Bhaviskar, who was using it for snake bite patients. And he says, this is great machine. I can operate it anywhere. There was a doctor in Sangli who manually operated it for 17 years on a child to keep that child alive. So we use this process for Bharucha ventilator. I went with mask and met Bharucha. He handed over. Can you just go through the slides? There is a slide showing photograph of Bharucha and myself when he handed over that. Mr. Bharucha is he's no more now, but I remember when in 75, when I came back from Holland, I met him once and he was working on medical devices, I remember. And I had carried a book of Tektronix medical devices in those days, and I gave him at that time, finding that there's a Pune person working in medical. So his vision was it should be for the benefit of all. He said, Ashok, take this, but see that it doesn't become a commercial, money-making thing. And I assured him that we got it home. I got it home. And I followed the same principle of divide and document and package. At the same time, each assembly, sub-assembly, and parts were measured, and I even made sketches. My grandson, who was 8 years old then, he helped me in that, in the whole process, as well as reminding me if I forget some part. Because as a child, he was looking at it as an object. So he could pinpoint that, आजोबा हा स्क्रू नाही काढला तुम्ही, हा वेगळा आहे, ओके ओके काढला, आजोबा हे हे याच्यापासून झालेलं आहे, हे इथं बाजूला ठेवू आपण. सो वी ऍक्च्युअली डिड दॅट ॲट होम. Then I released these photographs online, and then I don't know Bhairav Shah if he's here. I met him after 5 years physically, but he was online and he helped in creating CAD models of each part from the dimensions that I had drawn and the sketches I had drawn on paper. And I only had a 6-inch steel rule and one small toy vernier to take the dimensions. But I could manage proper sketches and give exact dimensions so he could make the models. Not only that, he made a working model in CAD. Then I think some group in NCL also got hold of that. But still, we were only at the about one week apart. For after 1 week, we had only the model of it. We had the information, but the need was physical, and all the factories were closed more or less, and there was no tooling, and there was no documentation with Bharucha. He was always making things almost by hand or by using the vendor skill, and that was one of the complaints that the customers were saying, that Bharucha only makes things in small numbers. So Vikas Chaitanya, my good friend from Aurangabad, Sambhajinagar, he always was available right from the day one when he left Philips, just because I was trying to motivate him to be available for producing workers who would learn how to produce electronics, which only the companies like Philips knew. He left the job and he devoted whole his life for promoting and developing electronic industry. He came forward. There was money required for doing tooling. We collected 10,000 first, somebody gave 15,000, and suddenly Rajiv Nath gave 10 lakhs, and then I could hand over the whole money and this prototype and the parts and the document to Vikas. He did a good job. He activated the entire ecosystem in Aurangabad and set up a capacity of producing 10,000 these machines per month. Practical. He made about 100 part sets, assembled about 30-40, physically drove and carried them to AMTZ Vishakhapattanam, got it tested. Unfortunately, because it did not follow the modern ventilator principles of using electronic sensors and giving indications and alarms, doctors found it as a very rudimentary, though it was a reliable device, and there was a resistance to it. There was a special meeting in Delhi. But the point is not that. The point is that this device fortunately was not required because Corona got over. And the normal expensive ventilators were made in large quantity and many companies got into it. But the process of reverse engineering could establish the manufacturing capacity of 10,000 ventilators per month at the cost less than 10,000 rupees each was an achievement. Now, reverse engineering and understanding the products we have seen every day in the repair mechanics on the street side. We have also seen how IBM PC was well documented, and if the information was available in the documented form, in the form of circuit diagrams, materials list, software listings, and so on, how Taiwanese could manufacture IBM PC and how there could be vast number of computers, so much so that all other models of computers are completely forgotten now in the world, and we only know computer as a PC. So there is a lot of power in sharing information, in extracting information. China has used this very much. Japan used it very much. When we were in Philips, there was no Japanese student. We were told that when Japanese come, they would document everything by seeing things, and then they would start making it. And so this process of learning from things and creating knowledge and information is extremely easy, available, and being practiced. Unfortunately, a lot of our engineering people, including me, when reverse engineering was being promoted as a way of working by Shekhar Kulkarni, I was fighting with him. I said, no, I'm an engineer. I would like to design from scratch and fundamentals and theory. And we had argument. He said, Rani, tu to ekdam garib hi rahega. Look at me, yaar, I'm just making this solenoid. I said, okay, fine, it's good for you. But I continued not doing reverse engineering. And then you have heard Girish, who followed that advice and how he became a good entrepreneur. So the point, the moral of the story is that it is an excellent process. It is an excellent process for rapid creation of information, knowledge, and even economy. It is something that should be practiced even in first year engineering, so that students will learn how to dismantle things and feel confident. Then learn that they can't put only names and description. They have to be able to make a picture, drawings. They will learn to make CAD models. They will learn to look around in the market to find how to get those parts. They will learn how to make those parts. Most important, even if they get the parts, they will learn how to systematically rebuild those products. And this, I think, is the power of this process. And having realized that power in this variety of ways, I'm trying to promote it as object-oriented engineering, because often reverse engineering was having a connotation, like in my mind, that it is copying and copying is bad. We are told right from childhood, don't copy, because we think copy is copying of answers in the exam paper. So copying is not the key part here. Learning, analyzing, and systematically creating document is the name of the process. So thank you very much for giving me this opportunity for explaining this concept, especially the APN part, which I actually invented as a out of necessity to manage about 60 students doing reverse engineering on all old parts in one workshop in the college. And this is when I thought of this scheme of numbering these part numbers as assembly part numbers. So one or two companies, while developing the new product, had followed this process and they have benefited out of the, but they were not doing reverse engineering. But I said, even if you are doing new part, in order to communicate what that part is within your organization, you follow this APN numbering as additional part number. We always have your storage part number, which is stores part number, which we can call SPN. And there is a manufacturer's part number if it is a bought out, which is external part. So that is MPN. So you have APN, SPN, and MPN are three ways of numbering the parts for creating information of any product. Thank you very much. If there are any questions, Vilas?
Yeah. Thank you, Ashok, for this wonderful presentation. We appreciate your efforts developing the ventilator. Let's throw open this platform for question and answer. Request everyone to identify yourself, name, and ask the questions. The platform is open. Please go ahead.
No questions?
No, please go ahead with your questions.
Then I have a question.
Yeah.
Like I gave you an example of a pen. Today, before end of the day, you please take any one object which you can fully dismantle and create this ball of material with the APNs. Believe me, doing it yourself is fantastic. You will, Sanjay, try
I
to do
Ashok.
it. Try to do that.
No, I had
Don't
a
miss
question. Wait.
a very small
In
part.
fact, I started it in my school days itself.
Take a
Yeah.
old shirt and dismantle it. Thank you.
Okay, Sanjay, go ahead with your question.
Yeah. Thanks. Hi, Vilas. Sorry, long
Yeah.
time no see. I was traveling a bit in Kashmir. Ashok, lovely to see you as usual. In fact, I just wanted to check with you how many of these principles actually you used for your first assignment at Philips when you were designing products. And the
Not
second thing that I was talking about is in current generation with automatic and QR codes along with RFID defining parts. I think there might be an ability to converge and have one single part number at various stages in the entire manufacturing process. Provided, of course, we have the equipment to identify as well as, classify. What would be your comment on that?
See, Sanjay, first of all, this methodology, when I was in Philips, was being followed very nicely by Japanese. That's why they stopped taking Japanese students without having this exactly same methodology, but I'm sure they were doing it, not telling me. Secondly, there is nothing like one standard and QR code and digitize. It is all about human mind understanding the relationship of the parts to which are constituent parts with the whole part. So therefore, I'm advising three numbers. One is this APN. A same screw may have different APN in different products. Physically, the stores have same number maybe. So SPN may be one. And same screw manufactured by three manufacturers will have three part numbers of three manufacturers. So
They become
once
unique.
APN or multiple APN in multiple products, single SPN in the store's part number in the company, and three or more MPN for manufacturer's part number. They are all equivalent. So it's not a panacea to have one unique number and digitize it with
No,
QR.
you haven't understood my question, Ashok. I'm not talking about a panacea. I'm not talking about a panacea.
It is about understanding the product, and the exercise gives you understanding, systematic way of understanding, so that you can handle large complex.
Got it. So the process and the labeling is what you're talking about, Ashok.
Right.
The process and the labeling, unique labeling, which allows clear identification.
And packaging it separately so that things don't get mixed up.
Yeah. Sanjay, that you got the answer. Any more questions?
हॅलो, मी मेहता, सतीश मेहता, विचारू का प्रश्न?
हो, बोला.
Hello,
हा,
Satish. Namaskar.
अशोक सर नमस्कार.
नमस्कार.
हा, माझा मी लेट जॉईन केले. तुम्ही ऑलरेडी प्रश्नाचं उत्तर दिलं असेल, पण याच्यामध्ये मला IP रिलेटेड म्हणजे इंटेलेक्च्युअल प्रॉपर्टी रिलेटेड आपण हँडल करावं लागतं का? म्हणजे आपल्याला परवानगी घ्यावी लागते की त्याबद्दल काही केसेस झालेले आहेत का आपण कॉपी करण्यामध्ये, आणि ते कसं हँडल करायचं? म्हणजे
सर, सतीश सर, मी एखादी गोष्ट समजून घेणे याच्याकरता पेटंट सारखा दुसरा मार्ग नाही ज्याच्यात एक्सप्लेन करून सांगितलेलं असतं. तसंच एखादी वस्तू पूर्णपणे डिस्मॅन्टल करणे आणि तिची रचना समजावून घेणे आणि ती परत असेंबल करता येणे, याला कोणाची परवानगी लागत नाही. तुम्ही त्याप्रमाणे तयार करून ती मार्केटमध्ये विकायला गेलात आणि त्याच्यामध्ये तुम्ही ती वस्तू आधी ज्यांनी केली त्याच्या इंटेलेक्च्युअल प्रॉपर्टीला धक्का बसत असेल तर तो तुम्हाला तिकडे कोर्टात नेऊ शकेल.
म्हणजे जर आपण विकायचा प्रयत्न केला तर.
परंतु तुम्ही ही पद्धत समजून घ्या. म्हणून तो रिव्हर्स पार्ट हा कॉपिंगशी रिलेटेड नाही आहे. हा प्रॉडक्ट पासून कॉन्स्टिट्युएंट पार्ट्स कडे जाण्याचा मार्ग म्हणून रिव्हर्स म्हटलेला आहे.
समजून घेण्याचा प्रयत्न.
आणि तुम्ही स्वतः निर्माण केलेली वस्तू एखादी असेल, तिचं सुद्धा असं अनालिसिस जर केलं तर ती तुम्हाला तुमच्या कंपनीतल्या किंवा तुमच्या ग्रुपमधल्या इतरांना समजावून सांगायला सोपी जाते.
ओके, थँक्यू सर.
अशोक, सुदर्शन बोलतोय.
हा, बोला.
एकच प्रश्न आहे की म्हणजे प्रश्न म्हणण्यापेक्षा काय, ते बरोबर आहे तुझं की समजून घेण्यासाठी त्याला काही रिस्ट्रिक्शन नाहीये, युजला प्रॉब्लेम येईल. पण काही ठिकाणी स्पेसिफिकली टर्म्स अँड कंडिशन, म्हणजे फॉर एक्झाम्पल मी एखादं प्रॉडक्ट घेतलं तर त्याच्यावर येणाऱ्या टर्म्स अँड कंडिशनमध्ये सॉफ्टवेअर असू दे, हार्डवेअर असू दे, त्या क्लिअर कट मॅन्युफॅक्चररनी सांगितलं असं की दिस इज फॉर यूज ऑफ दिस, इज नो कॉपिंग, दिस इज नो रिव्हर्स इंजिनिअरिंग ऑफ दिस, इज नॉट अलाउड विदाउट द परमिशन ऑफ दॅट. सो असे काही ठिकाणी त्याचे क्लिअर कट इन्स्ट्रक्शन त्यांनी दिलेले असतात की तुम्ही करणं अपेक्षित नाही, करायचं नाही. म्हणजे फॉरगेट अबाउट ऍक्च्युअली वेदर यू आर गोइंग टू अंडरस्टँड इट ऑर सेल इट. तर काही ठिकाणी असे नॉर्म्स बघितले आहेत मी, म्हणजे इफ यू गो विथ ऍक्च्युअली द क्लॉजेस ऑफ दॅट पर्टिक्युलर प्रॉडक्ट. त्यामुळे कुठेतरी असू शकेल, पण मोस्ट ऑफ केसमध्ये इंडिव्हिज्युअल पर्सनलसाठी की समजून घेण्याची प्रोसेस मात्र चांगली आहे, की एक पार्ट घ्यायचं, त्याला ब्रेकडाऊन करायचं आणि समजण्यासाठी रिअसेंबल करायला एक स्टेप बाय स्टेप, ती प्रोसेस डेफिनेटली चांगली आहे, काही शंका नाही.
आता मला त्याच्याबद्दल एक विचारायचं आहे. जुन्या बाजारातून एखादी वस्तू आणली ॲज अ स्क्रॅप, ती स्क्रॅप करायला त्याला परवानगी नसेल, पण ती चूक कोणीतरी केली आणि ती स्क्रॅप करून टाकली आणि मी ती आणली. आता त्या वस्तूचे लायसन्स किंवा त्याचे टर्म्स काही माझ्याकडे आलेले नाहीये, त्यामुळे ते मला अप्लिकेबल पण नाही. त्यामुळे
नाही,
मी ती
जनरली तसं
उघडून
नसतं.
नाही,
जनरली
ती मी
तसं नसतं.
उघडली.
म्हणजे स्क्रॅप केलं म्हणजे टेक्नॉलॉजी स्क्रॅप केली असं त्याचा अर्थ होत नाही.
नाही,
त्याच्यामुळे
स्क्रॅप टेक्नॉलॉजी स्क्रॅप नाही केली, परंतु मी जुन्या
नाही,
बाजारातून
प्रॉडक्ट
वस्तू
ते
आणली.
म्हणलं की आपण जेव्हा प्रॉडक्ट रिव्हर्स इंजिनिअरिंग करतो त्यावेळेला त्याचं टेक्नॉलॉजिकल आस्पेक्ट समजून घ्यायचा प्रयत्न करतो. म्हणून त्याच्यामुळे स्क्रॅप मधनं आणली म्हणजे त्याचे राईट्स गेले त्या मॅन्युफॅक्चररचे, असं होत नाही. म्हणजे लेट्स नॉट ऍक्च्युली गो इन टू डिटेल ऑफ दॅट. आय एम जस्ट जनरली टेलिंग.
सर, माझा
त्याच्यामुळे
एक पॉईंट
मला असं वाटतं
ऍडिशनल
की
आहे.
प्रॉब्लेम नाही.
मला असं वाटतं की हा वेगळा सब्जेक्ट आहे, त्यावर
हा.
आपण
नाही, माझा एक याच्यात
discuss करू.
ऍडिशनल
आता
पॉईंट
आपण
आहे, मी जस्ट
फक्त
मेन्शन
रिव्हर्स इंजिनिअरिंगच्या बाबतीतलेच प्रश्न उत्तर घेऊ. सो एनी मोर क्वेश्चन अबाउट
हॅलो,
रिव्हर्स इंजिनिअरिंग, प्लीज गो अहेड.
जरा मी यात कॉन्ट्रीब्युट करू इच्छितो.
हो, प्लीज गो अहेड, विनय,
मी विनय
प्लीज गो
केळकर.
अहेड. विनय केळकर, प्लीज गो अहेड.
हा,
लेट मी आन्सर.
बेसिकली सर,
Reverse
याच्यात मला
engineering-
एक असं वाटतं की हा रिव्हर्स इंजिनिअरिंगची जी प्रोसेस आहे ती आपल्या जुन्या टाईपची जी काही यूज मशिनरी वगैरे असेल आणि त्याला जर कधी रिपेअर मेंटेनन्सची वेळ आली तर त्यावेळेला ह्या टाईपची प्रोसेस नक्की उपयोगी पडू शकेल.
ही सगळ्या ठिकाणी उपयोगी पडते प्रोसेस. जुन्या काळी माणसांची कलेबरं घेऊन त्याचं रिव्हर्स इंजिनिअरिंग समजावून घेण्याकरता अनालिसिस करून डॉक्टर तयार झाले. आता त्या काळात सुद्धा कलेबरांना हात लावणे अलाउड नव्हतं, परंतु ज्ञान निर्मितीची ही प्रक्रिया म्हणून समजावून घ्या. बाकी त्याचे लिगल आणि एथिकल ऍस्पेक्ट्स हे नंतर बघा, तो वेगळा विषय आहे.
लेट सम लॉयर आन्सर दिस क्वेश्चन. ओके,
सर
नेक्स्ट
मी
टेक्निकल
बोलू
क्वेश्चन
का
प्लीज.
एक मिनिट? सर
हो,
मी
बोला
गिरीश
गिरीश.
रानडे बोलतोय. सराफ
Girish
सर
is one of the
नमस्कार.
rather bhakta of reverse engineering. Please go ahead, Girish.
नमस्कार सराफ सर, थँक्यू
नमस्कार.
सो मच फॉर म्हणजे मी असं म्हणू शकतो की पार्ट 1 जो होता माझा, त्याचं पार्ट 2 आपण खूपच छान एक्सप्लेन केला आणि ब्रेकिंग इट डाऊन. म्हणजे माझे 2-3 पॉइंट्स असे होते की म्हणजे प्रश्न नाही आहे मला, पण माझे पॉइंट्स मला मांडायचे होते टू कन्सॉलिडेट युअर पॉइंट ऑफ व्ह्यू. की ही जी प्रोसेस आहे ही आम्ही रेग्युलरली डिझाईनमध्ये पण वापरतो आणि रिव्हर्स इंजिनिअरिंगमध्ये, म्हणजे रिव्हर्स इंजिनिअरिंग इज अ पार्ट ऑफ डिझाईन. हे मी माझ्या पहिल्या जे पार्ट
Correct.
1 होता त्याच्यात पण मी
Absolutely.
सांगितलेलं आहे.
You're right.
आणि म्हणजे रिव्हर्स इंजिनिअरिंग इज अ पार्ट ऑफ डिझाईन प्रोसेस आणि त्याच्यात ही सगळीकडे वापरली जाते. दुसरं सराफ सरांनी फार छान सांगितलं की देर इज नथिंग टू बी अशेम्ड ऑफ इट, शाय ऑफ इट. आपण ओपनली आम्ही कॉपी करतो म्हणायचं किंवा रिव्हर्स इंजिनिअरिंग म्हणायचा हा आपला विषय आहे. काही आपण म्हणू शकतो, पण इट इज इक्वली डिफिकल्ट. ते काय एवढं सोपं नाही. हा दुसरा पॉईंट. तिसरा पॉईंट असा आहे की पेटंटबद्दल आता खूप चर्चा झाली. तर असे लाखो हजारो प्रॉडक्ट्स आहेत जे पेटंटच्या बाहेर आहेत आणि असेही आपल्याला खूप उपाययुक्त आहेत की ज्या पेटंटला सर्कमवेंट करू शकतात. त्याच्यावरती पण एक लेक्चर आपल्या टेक फोरमवर नंतर झालं होतं. आणि सो हा माझा तिसरा पॉईंट होता. आणि चौथा मेन पॉईंट असा आहे की हे रिव्हर्स इंजिनिअरिंग हे फक्त वैयक्तिक समाधानाकरता नाही आहे, हा बिझनेस करायचा आहे आपल्याला. प्रॉडक्ट रिव्हर्स इंजिनिअर करून आय वॉन्ट टू सेल इट, मेक प्रॉफिट्स अँड बिंग आणि आपल्या देशाचं भलं करायचं आहे. असे माझे 3-4 पॉईंट्स होते. थँक्यू.
Well defined, well defined. Girish, thank you for defining this.
थँक्यू.
And
आत्मनिर्भरतेचा मार्ग आहे.
any more questions? Or interaction, comment, whatever. We have a good number of people present today, so this
Hello.
is a very interesting. Yeah, go ahead, please.
Vijay Gate.
Oh, Vijay, please go ahead.
Hi, Ashok. How are you?
Yeah.
Okay. This method that Ashok described, I've been using it all my life.
Oh, great.
Though, of course, numbering scheme, I was numbering it as 1.1.1, 1.2.1, and so on. So instead of letters, I used to use numbers. Now, this process is useful in both the forward engineering as well as reverse engineering.
Yeah.
Because forward engineering, also you need to structure what you are producing. And Vilas, you might know this. one of the most important final output of a design, product design in Philips used to be what was called standard part list or a structured part list.
Yeah.
Right? Okay. One more benefit of this type of discipline while doing reverse engineering is when you need to understand and try to rebuild a product, you need to understand relationship between various parts. So when you break down the product this way, you can also say, yes, this relationship I understand, this I don't understand. So you need to focus further on that particular relationship. I understand this part, I don't understand this part. So how much do you know and how much you still need to work on? I think this type of document also helps there.
Yes.
Yeah. And thanks, Ashok, for sharing this.
Yes,
Yeah,
Vijay, you are absolutely on
good
the
input. Good input, Vijay. Any more questions or comments?
अजून एक जस्ट कॉमेंटच आहे. मला
बोला.
वाटतं आपली जी जुनी हिस्टॉरिकल स्ट्रक्चर्स असतात ती ज्या वेळेला रिपेअर करायची किंवा काय त्याला रिकन्स्ट्रक्ट करायची वेळ येते त्यावेळेला पण त्याचे प्रत्येक स्ट्रक्चरचे काय दगड असतील किंवा त्याचे पिलर्स असतील ते असे सिस्टमॅटिकली सेपरेट केले जातात, त्याला नंबरिंग केलं जातं आणि त्याच्यानंतर परत त्यातले काही मिसिंग पार्ट्स असतील ते काढून मग त्याला परत रिअसेंबल करून ओरिजिनल स्ट्रक्चर कसं परत येईल हे पाहिलं जातं. So I think the system is
Good
similar.
example, because this is a temple relocation, and I
Exactly.
have seen this at many places.
Yes,
Yeah,
exactly.
this is also a good example.
Vilas, I want to add one line. Everybody talks a lot about we are importing everything from China, whether it is toys or whatever. If you take anything and try to disassemble it in this systematic fashion and document it, maybe you don't want to make it yourself, but doing that work doesn't take long time. But if you spend that work and give that document to some other person, he'll be helped a lot in taking it further. Give him an object की भाई हा पेन आहे, हा कसा करायचा माहितीये का, हे बघा हे पार्ट्स करायचे असतात, या प्रत्येकचं हे ड्रॉइंग आहे, हे कॅड मॉडेल आहे. आणि या लेवल पर्यंत जर आपण टेक्नॉलॉजी, सपोज वी ब्रिंग द टेक्नॉलॉजी इन द रिव्हर्स वे अप टू दिस लेवल, and if there is a money available at the dice level and make it openly available as a donated technology, wonderful things can happen. We have huge market for each of these small things.
Yeah. I think this gives me an idea that Tech Forum should start.
Who otherwise have to become chaiwalas because they don't have access to what we call technology, and they do not have ability to generate that technology. We have ample number of engineers and retired engineers and not working engineers who can do this work very well to create the free CAD, excellent CAD models also of all the objects, and also understand the processes. Create a document and give that file as a gift. जैसे भूदान दिलं ना,
It's a working document.
असं माझी
Yeah, good. I think that gives me an idea. Tech Forum should start this process.
Tech Forum is ideally positioned to do it.
We'll see, because we have Girish, we have Ashok, we have Vijay Ghate. So these are the people who are really worked in this field. So we can try to take one assignment and see whether we can do it. Anyway, thanks a lot for all these inputs. But I must thank Ashok for this very good presentation with a simple example of a ball pen reverse engineering to Barucha ventilator. So thanks a lot, Ashok, and everyone who participated and reacted actively.